In this video, we're going to learn how to write equations using words, or actually either writing an equation using words or using words to write chemical equations. So by the end of this video, we'll be able to take this sentence, solid zinc is added to aqueous hydrochloric acid to form aqueous zinc chloride and dihydrogen gas. So we're going to translate that and write a chemical equation. In a separate video, we're going to balance those equations. So we're going to say balancing for the next video. Okay, so here's another example that we'll try to address at the end by the end of the video. So oxygen gas is added to hydrogen gas to create water vapor. Okay, and then we'll be able to write an equation for that as well. Okay, so here's in your vocabulary sections. There's some things in that sentence, that previous example, to learn what they mean, like certain notation, what they mean. So this means something, this AQ here, this S means something. So these are states of matter during a chemical equation. Okay, so these, first of all, these are, so number in your vocabulary, this may be around number 40. You may have to double check. Okay, so this could be number 40. So this is possibly 40. You'll have to double check in your notebook. So these over here are the reactants. These are the substances that go into chemical reactions. And then on the right side of the arrow, they're separated by this arrow. And these are, of course, the products. So this is kind of like a before, and then we have arrow, and then after. And then the whole thing from left to right represents the progress of the reaction. So coefficients are these numbers. You'll see these numbers in the front of the reactants and in front of the products, these numbers here. They tell you the proportions or relative numbers of particles involved in reaction. So those are those numbers. So so you want to list these in your vocabulary section. So this may be 42. Again, double check. Okay, and then this would be 43. And then a few other things on this slide. These subscripts, these we've covered already. These right here, these are how many atoms of that element that it's next to there are in that compound. So those are those numbers. And then the phase or state of matter is indicated in parentheses after the whole substance. So here's the whole substance, and then here's the state of matter. That would be those there. Okay, so and again, number these. This will be 44. And like I was saying, double check in your notebook. Okay, so moving on. You'll see that, let's go back for a second to these word equations. And in this equation, you'll see that hydrochloric acid, zinc chloride. So some of these things are covalent, some are ionic, and really we're just naming these, and then we're going to apply the vocabulary terms from this slide here in order to translate those words into chemical equations. So let's do a naming refresher. Okay, so for you guys, I want you guys to try to name these. I'm gonna do some of these. So I'll be doing this one and this one as examples, and then you guys should be doing these here. So you guys do 2, 3, and then number 5 also. Okay, so BaO. So remember, these are ionic. So you just name the cation. So they consist of a cation. They have cations, and so they have cations, and they have anions. So they have cations and anions. Okay. And we just named the two things, and you changed the ending to "ide." So that's all there was to ionic. So this is the cation is barium, and the anion is oxygen. And instead of oxygen, we're going to change this to "ide," so we'll call it oxide. So barium oxide. Okay, and then you guys try 2 and 3. Remember, also give you a hint here that you'll have to, with ionic, you'll have to remember your polyatomic ions, and also oh yeah, the transition metals. So if it's a transition metal, then those, you have to specify the charge it makes with Roman numerals. Okay, that only appears in the name. This is like a really detailed thing, but it comes up if you have a transition metal. So if you go from name to formula, it's a little bit harder because you have to come up with the correct charges that they make. So if you recall, aluminum is in the, so here's a badly drawn periodic table. It's still badly drawn, but you get the idea. So it's in 3A, aluminum, and then 3A, so Al is right here, makes a 3+ charge. Oxygen is over here in column 6A, and it makes a 2- charge. So we need to write out the two ions that it comes from. So we have Al 3+ and 2-. So remember, with ions, the charges are from the column numbers. So use your periodic table, or it could be a polyatomic ion, and in that case it would have to come from memory, from memorizing them. So, and then for the formula, this is a 3+, this is a 2-. To get them to balance correctly, the two charges, you would need 2 aluminums and you would need 3 oxygens. So that means that 2 means you have 2 of these, and you have 3 oxygens, 1, 2, and 3. So a net total of 6+ and a net total of 6-. So that's why you have the 2 here. So that's why you have the 2 here, and then the 3 is here. Okay, and you guys try number 5. Okay. So we also, if you remember that word equation that I had at the beginning of this video, it had ionic and covalent in the same reaction. So you could have like gases forming, which are usually covalent, and these could be reacting with things that are ionic. So you could have ionic, covalent in the same chemical reaction. So it just all depends what's reacting. So we have to refresh how to name ionic compounds and covalent. So here's some more ionic for you to try. I'll do number 6. Actually, I'll have you guys do 6 because this is really just review. Okay, and then I kind of talked about how to do these already. So remember your polyatomics. Okay, you're gonna have to remember what those were, and then list that ion here and here. And then these, you get these charges from the periodic table. So again, the charges are either from the column number or from it being a polyatomic ion, and then just recalling what it is, that ion. Okay, so we're going to also have to review covalent, so naming covalent compounds. So there's a note we need to make that these are really common to form during chemical reactions are gases. Gases oftentimes evolve as products. Sometimes they react on the reactant side, but many times they evolve from a reaction. So you mix 2 ingredients and then gases come out. So there's 7 elements on the periodic table that exist in diatomic form. Everything else on the periodic table can exist monotomically other than these 7. It actually forms a 7 on the periodic table. So let me try to draw a little bit better looking of a periodic table than I did before. Okay, and so there's 7 things. There's N, O, F, Cl, Br, and I. That's 6 things, and then the 7th is H. So these are the 7. I like it because it kind of makes a 7 there. And then this right here that's actually only 6, but then there's the 7th one right there. So there's 7 elements that make diatomic gases. That means they do not exist like this. They exist like this in diatomic form. It also makes a mnemonic called Hoff-Brinkel. Okay, and those are the 7 diatomic gases. Is this Hoff-Brinkel. So if you wanted to write out hydrogen gas, you would not just write H. It's H2. So if you're reading one of those word equations and they say chlorine gas is evolved, okay, then you would write Cl2 for the name of the gas. Okay, so I'll do number 2, and then I'll have you guys try this one, number 3, to write this one. Okay, so number 2 is dinitrogen monoxide. So that means you have 2 nitrogens and 1 oxygen in that compound. And then boron trifluoride. Okay, remember the mono is only if there's one of the second atom. So you won't have mono if it's one of the first ones. So it would be BF3 for boron trifluoride. Okay, you guys were supposed to answer that one, but whatever. So we'll get practice on those anyway when we start writing out word equations. Okay, so here's a word equation. Okay, it says aqueous silver nitrate is added to aqueous sodium chloride, which forms solid silver chloride and aqueous sodium nitrate. Okay, so here's our, so we're going to take this and then translate that into a reactant. So silver nitrate is silver makes a 1+. It always makes a 1+. And then nitrate from memory is NO3 minus 1. Okay, so our ions are 1 and 1. So silver nitrate is going to be AgNO3. And it says aqueous. So that means aqueous means it's dissolved. So aqueous means AQ means dissolved in water. And that's what AQ means. So we're going to write AQ, okay, as opposed to solid. So this exists as a solid, AgNO3. When you add it to water, it dissolves, much like sodium chloride, like table salt would. Okay, and it says is added to. So is added to is going to be plus. So we're naming the 2 reactants here. Plus aqueous sodium chloride. Okay, so sodium is a metal. And chloride is a nonmetal. So this is an ionic compound because we have a metal and a nonmetal. So it's going to be Na plus and Cl minus. And we would have gotten those from the columns, column 1 and column 7. So sodium chloride is going to be NaCl. And it says aqueous. So we write this is also dissolved in water. So that's AQ. And it says which forms right here. So that's going to be our reaction arrow. And it says solid silver chloride. So silver chloride is going to be Ag plus and Cl minus. Notice what happened here is the cation from one of the reactants combined with the cation of the other. Of the anion of the other. So this cation, this is called a double replacement reaction, combined with that one. And then the other 2 actually combine also. So the sodium and the NO3 also combined. Okay, so this and this combined. Double replacement, meaning the cation and anion swapped partners. Okay, so that's going to form solid silver chloride. So Ag plus is my ion and Cl minus 1. So it's going to be AgCl 1 to 1. Okay, and it says solid this time. So it's actually in parentheses S. So you have a clear liquid, another clear liquid, and it's going to make a white cloudy substance. So, which is kind of strange if you think about it. You have 2 liquids, and then somehow like this solid powder starts sinking to the bottom when you mix these 2 together. That solid powder would be silver chloride. So AgCl. It says and your other product. So and would be plus aqueous sodium nitrate. So your 2 ions this time are going to be sodium and then nitrate. So it's going to be, again, 1 to 1. So it's going to be NaNO3. So you would crisscross those charges. And this also, so this would be aqueous. So we write parentheses AQ. If we knew how to balance, I'm going to cover balancing a separate day, but you would check to see if all of these atoms on this side equal the number of atoms on this side. And you'll see that they do. There's one silver on this side. There's only one silver, and there's one silver on this side. One nitrate here, one nitrate here. Everything's 1 to 1. Okay, and you'll notice it's because all the charges were 1 to 1. So something to remember when we start balancing. Okay, so that's our chemical reaction. So you guys tried this one. So this will be your turn. So do this in your notebook. Okay, we have not named acid, so I will give you the formula for this one. It says hydrochloric acid. This is that's actually a second semester topic, but this is going to be HCl. That's hydrochloric acid. So I'll give you the name of that one. Okay, so I'll see what you guys come up with tomorrow. That's the end of our video.